Let's look at problem number 3 from the exam number 2 from ECE 207 in the summer of 2007. This particular problem says to find the impedance for each resistor, inductor, and capacitor, and assume the source voltage is sinusoidal with an amplitude of 6, a frequency of 5 radians per second, and a phase of 45 degrees. What we have to remember is that we're working in sinusoidal steady state and we want to find these impedance values. The only thing that we really need to know from the input voltage source relative to finding these impedances is the frequency. And the frequency in this case is given to us as omega equal to 5 radians per second. Once we know that and remember our formulas, we have the impedance for a resistor, Z sub R, is just R. The impedance for an inductor is J omega L, and the impedance for a capacitor is 1 over J omega C. If we have those, it's now pretty straightforward to find all of the impedances for the different elements, circuit elements. For R sub 1, let's call that Z sub R sub 1. That's simply R sub 1, which is 4 ohms. And all of these have units of ohms, the impedances. For R sub 2, we have Z sub R sub 2. That's simply R sub 2, which is 10 ohms. Those were pretty straightforward. The others are too. All we have to do is plug those values for L, use the omega that we've just found from the source, which is 5, and plug those into the appropriate formulas. For our impedance of the inductor, Z sub L, or to be consistent with what we've been doing notationally or for this problem, for L, Z sub L is just J omega L, which is J. Omega is 5, and that's in radians per second. That's the only hard part of this problem. We need to make sure our units are consistent. L needs to be expressed in henries, and we now have that Z sub L is simply J times 0.05, or you could have said that that was 0.05 at 90 degrees. Either of those answers would be correct, depending on how you want to use it. If you're going to be dividing by things, you might actually want it to be in the polar form versus the rectangular form, but they're basically right there next to each other in terms of what they are. For the capacitor, Z sub C, the impedance of the capacitor, that's 1 over J omega C. Again, we just plug in our frequency of 5 radians per second. Our capacitor value is 250 microfarads, and micro is 10 to the minus 6, and we're basically then done with this problem. We can clean it up a little bit. We can multiply by 1 if we want to, where 1 is now this J over J, and remembering that the product of J times J, or J squared, is minus 1, then we have minus J, and downstairs we could say we have 1.25 times 10 to the minus 3 ohms, or we can take all of that upstairs, and we now have that Z sub C is equal to minus J, and that when we invert the 1.25 times 10 to the minus 3, we basically get something that's a little less than 1,000, and that ends up being minus J 800 ohms, or if we move the minus J to its angle and polar form, we could just as easily write that as 800 at an angle of minus 90 ohms. And that completes problem 3.